Hello, everybody. Welcome to the Red River Apiarist Association April meeting for 2022. We have our guest speaker tonight is Derek Micholson of the KRTP, who's going to do a talk on sustainable queen rearing. Did I get that right, Derek? Pretty much.
Close enough.
Close enough. Excellent. We've started the routine of starting with our speaker. Just out of courtesy. So we are going to have Keith Bamford introduce Derek, and without further ado, we will get the lead talk on the way. Keith, I hand it over to you.
Yeah, hey, thanks. Yeah, we're really excited to have Derek speak to us tonight, and I think I'll keep the introduction really quite brief, and just say that Derek was appointed the program lead of Manitoba's first tech transfer program, the Knowledge Research and Transfer Program, or KTRP, and he's been working at his job for a year, and he was very amenable to taking on this presentation, so we really appreciate it. And he's going to cover some of the benefits of splitting for increased basic biology related to queen rearing, some of the different methods of rearing your own queens, and touch on some basic elements of bee breeding. So, and I think the presentation title is an introduction to queen rearing for self-sufficiency. So I think you can just take it away, Derek.
Thank you, Keith. Yeah, I guess I will just share my screen here. Hopefully you can all see that now.
Yep.
Yeah, so thanks a lot for the invitation to speak tonight. I must admit, I put this presentation together. I just finished it today and haven't really ran through it too much. So hopefully it's roughly around the right amount of time. I think it's 45 minutes or about that. I guess before I begin the talk, though, I did want to mention that the KRTP is looking at putting on an in-person queen rearing workshop this summer. It'll very likely be on June 25th. So I guess you could kind of use this presentation as a bit of an introduction to kind of the background of queen rearing and making splits and that sort of thing. And then hopefully if this in-person thing goes ahead, we can do some actual hands-on stuff, and people can practice grafting and that sort of thing. So I would say go ahead and mark June 25th down on your calendar. And unless there's any inclement weather or something, it should be happening on that date. So the other thing I'd like to mention is that the KRTP Bee Health Monitoring Program is still open for anybody that would like to sign up. There's lots of space left. We actually just decided on hiring someone yesterday. So we are hiring someone for the season, and that should be able to expand the amount of people that are participating in that program. So if you're interested, just send me an email. I'll send you the details, and you can sign up for that if you're interested. So yeah, so I guess, today we'll be just talking about an introduction to queen rearing for self-sufficiency. And so just sort of basic biology related to queen rearing, just some introductory stuff, and we'll cover some of the different methods, as Keith mentioned. But really, if you're a beekeeper, I think every good beekeeper should learn how to rear queens at some point. I think it's a skill that every good beekeeper should know how to do, and it'll really allow you to become a much more self-sufficient beekeeper, and you can move away from buying bees and making your operation a little bit more expensive. I know this particular year was pretty hard, and there's a lot of large losses and a lot of things that were probably outside the realm of things that beekeepers could actually control through management. So it was a tough year for everybody. So not trying to, scold anybody for not being a self-sufficient beekeeper. I know there was a lot of things that happened this year, but I think there's a lot of stuff in this presentation that, maybe you could pick up on to try to mitigate some of those larger losses. So yeah, just again, on colony losses. Colony losses are a natural part of beekeeping. It's going to happen every year. You're going to lose part of your operation. As long as you have, sufficient numbers that survive, you should be able to at least rebuild part of those losses, if not, over and above what you've lost. Again, this was a tough year, so that might not be possible for as many beekeepers, and they might have to rely on buying bees and that sort of thing. But yeah, as long as you can start rebuilding, there's a number of ways that you can kind of recoup those losses. Of course, you can be buying package bees. This is often challenging when package bees aren't available. It can also be very expensive. I know Dr. Curry bought some packages at the university this year, and I think they were about $275 a package. So I think the price of packages is always increasing, and it can be hard to find. So it becomes quite expensive and unreliable. Of course, you can buy hives or nukes to make up those losses. Again, quite expensive and maybe unreliable, especially in years like this when a lot of other beekeepers have had some pretty high losses. And you could rely on catching swarms if you like to kind of make up those losses. But again, that's going to be a very unreliable way of recuperating those losses. So probably, the methods that would be more sustainable and allow you to have a little bit more self-sufficiency would be to make your own splits to recuperate those losses. So obviously you would need to requeen those splits. So you can either do so by buying queens, which again is quite expensive. As John mentioned at the beginning, they're upwards of $45. I think I've even seen queens for $50. So they can get quite expensive. You can buy queen cells, which is a much cheaper method of requeening a colony, but they're not always available and not always available when you need them, similar to actual mated queens. So rearing your own queens is, going to be ultimately the cheapest method for you to be able to requeen splits, and they would be a lot more available when you need them if you're able to mass produce enough queens to recoup your losses and maybe even more than you need, and maybe even either give some away or start selling some queens. So just covering some of the costs and benefits of splitting your colonies. So first off, basically the overall cost of making a split is that you're removing resources from some of your stronger colonies, and which would ultimately result in less honey being produced from those really strong colonies. That said, if you have a lot of strong colonies and you don't do anything, they're very likely to swarm. So you may be losing those resources anyway. So some of the benefits of splitting are you're able to slow the growth of those really strong colonies and reduce the urge to swarm. You take brood out of those colonies, give it some more space, reduce the urge to swarm. Other benefits are replacing your dead outs and increasing your colony numbers. So either increasing to where you were the year before, or maybe you want to grow your operation and increase as a beekeeper. And another benefit is that brood breaks can actually help with Varroa as well. So if you're splitting your colony, especially if you're using queen cells or unmated queens to put into those splits, there's going to be a break in the brood cycle. The mites are going to go through a period where they're not going to be reproducing as much. And so that can be kind of an integrated pest management strategy for controlling Varroa a little bit. It's not going to, can't rely on that, but you may be able to suppress Varroa a little bit. So one of the big things I wanted to drive home with this is thinking ahead, and if you're going to wait until you have your colony losses the following spring, you're probably going to be in a situation where you may not have the resources to actually rebuild your colonies. So if you think ahead and plan in advance, you're going to have some amount of losses. just think about making up your replacements before. So why not make them up the year before, when those resources are available, when you have the actual bees and the brood to make up splits, and then put those splits through the winter and hopefully have those replacements available right at the beginning of the season. So you can increase your winter survival numbers if you're putting double, depending on how big of a beekeeper you are. If you only have 10 colonies, if you make 10 splits, you put 20 colonies into the winter and you only have 50% survive, you're still back to 10 colonies where you started. So you can increase your winter survival odds that way. And it can just result in you becoming a self-sufficient beekeeper and not having to always rely on spending money to recoup your losses the following year. And if you have a really good year, you could end up selling excess bees, or looking at other ways of diversifying your income through your beekeeping operation. So some of the methods of splitting. So first off, there's just walk away splits. Basically just taking bees and brood from a strong colony, taking a frame of eggs, just putting it off to the side and just walking away, let them rear their own queen. And so one of the kind of the methods of this, I'm just going to get a laser pointer here, is a vertical split or a horizontal split. So just kind of going through different colony manipulations, you can do what's called a vertical split, where if you have the queen down here and all the brood, you can take the top box. If this was a double brood chamber colony, remove the top box, just place a division board or an inner cover or something upside down with the entrance. You would reverse the entrance, so those bees flying out of the top would go down into the bottom, and then come back a few days later. That queenless box at the top would then be starting to produce queen cells, and then you can just kind of take that box away and let them rear their own queen. You can also go through the removal method, basically just actively removing brood and bees from strong colonies. If you have a number of pretty strong colonies that can't really be divided into two, you can take brood and bees from multiple colonies and just make up one split from multiple colonies. Or if you have a super strong colony, you could make up probably 2 or 3 splits from a really strong colony. There is a difference between splits and nukes. Nukes, you're not really going for a honey crop in that first year. You're kind of just making up a nucleus colony, basically, just the basics of what a colony would need to be able to expand throughout the season and be able to produce a honey crop for you the following year. A split would be, you're actually going for a honey crop that year and giving it a lot more resources. Of course, you want to think about timing when you're splitting. You don't want to be splitting too early. If you're relying on buying queens, especially, often can't get queens until into May, so you wouldn't want to be splitting your colonies quite yet. If you're going to be relying on the colony to requeen itself just through building its own queen cells and then mating, you also have to think about the amount of time that takes, but also you need to think about having ample amounts of drones. Drones typically aren't really produced en masse until later into May, and they take time to both develop and then mature sexually. So you have to think about timing. So probably waiting until mid-May or the end of May to actually start making up your splits. This is right off of Ian Stepler's YouTube page, just a method of splitting without actually finding the queen. So typically a lot of beekeepers are going through their colonies, spending a lot of time finding their queens, putting them off to the side, and making sure they're not taking their queens away with their splits. This is a really great method. Ian just has a kind of a tote that he's mounted to an inner cover here that's just cut out, which can just be placed right on top of a colony. There's other ways of doing it. You could just use kind of an empty shell placed on top of a colony. But basically you would, if you don't want to find the queen, take that second brood chamber off, put it off to the side, shake all those bees down into the tote. All those bees would just go down into that bottom box. You then put a queen excluder on that bottom box, put that second brood chamber right back on. All those worker bees would just come up to the second brood chamber and the queen would be trapped down below. So that would be a really quick way of making a split. Then you could, come back later after all those bees had gone up into that second brood chamber and just basically take that box right off. So the methods of obtaining queens, so you can either purchase your queens, you can kind of rely on natural development, or you can rear your own. So the rest of this presentation, I'm not going to touch on the purchasing, but kind of focus in on these second two methods here. Before I do, just covering some of the advantages of rearing your own queens. It's super fun and rewarding. I think it's one of the most fun parts of beekeeping, and rewarding in that you're producing your own queens and having really strong, healthy colonies that you made yourself without having to spend any money on it. So you can save a lot of money that way. Often these queens are even better than purchased queens. You're buying queens through the co-op or also through a queen breeder, but usually queen breeder queens are going to be pretty good. But if you're buying queens that are shipped from other places of the world, often you put those in your colonies and they requeen themselves pretty soon, and they're often not very good queens. So rearing your own queens, you can often have better queens than you would actually buy. They're going to be also more attuned to the local environment, which is really important, especially for overwintering. If you're buying queens from New Zealand or Hawaii, these queens aren't attuned to the Manitoba environment. So there's an advantage there that they're going to be attuned to local Manitoba environment. Another advantage, of course, is that you're going to have replacement stock, so you can make up nukes or just use those queens to requeen old queens or what have you. And queens are going to be available when you need them the following year. And if you have a really good year, you have too many queens, you could end up selling queens and turn a decent profit at it. So just moving into some of the reproductive biology. So of course, we all know the three castes of bees: the worker, the queen, and the drone. And just to kind of go over the life cycle again, very importantly, of course, just to drive home that the queen life cycle is substantially shorter than the worker life cycle. Queen or the development time of a queen is about 16 days, whereas a worker is 21 days, and a drone is about 24 days. So when we're rearing our own queens, we're usually going after this period right here. We're not grafting eggs. They're too fragile. We're using these young larvae. Basically, we're using the youngest larvae that we can find. Often people say you should be grafting the larvae that you can't even see. So the smaller the better for grafting. But if you're wanting to go after these young larvae, basically you can kind of forget about those 3 days of the queen's development, and the rest of that development from the time that you start grafting, that's going to shorten this queen's development down to about 12 or 13 days. So just looking at some of the natural reasons that colonies would rear queens, So there's emergency situations, as you can see here in the top picture, where something has happened to the queen. Either the queen has died from natural causes, or maybe the beekeeper squashed the queen by accident, or something's happened to the queen. Those worker bees are going to create a whole bunch of emergency cells. You're going to see a bunch of cells like this on the comb. Often those cells will turn out to be quite inferior queens, because they may be choosing larvae that are a little bit older. Those young larvae are going to end up being the most superior queens. And so if these bees are choosing an older larva to start rearing a queen from, what will happen is that queen will actually emerge first if they pick a 3 or 4 day old larva versus one of the a 1 day old larva. Those older larvae are going to emerge first, and they're going to run around and kill all those other queens, and you're going to be left with a pretty inferior queen. The other reason colonies would rear queens is, if there's a failing queen, the queen's still there, but she's old, she's not laying properly, or maybe she's diseased, or something going on with that queen that the colony wants to supersede that queen. And so you'll see queen cells like this on the frames again. These supersedure cells will be often a little bit more superior in quality to these emergency cells when they're rearing massive amounts of these emergency cells. But ultimately, those supersedure cells can also result in inferior queens. Swarming is really probably going to produce the best queens. This is a time when the colony is in a resource-rich environment. The colony is booming. It's the population is through the roof. It's there's a lot of resources coming in, and it can really rear some pretty good queen cells. If you end up cutting out a queen cell, and this is another method of making a split, is you can cut out these queen cells and use them. But if you cut out swarm cells, what you're actually doing is basically selecting for swarming behavior. Swarming is has a genetic component to it. So if you're using swarm cells, you may end up selecting for that behavior and find that your operation as a whole is very prone to swarming. So looking at the female cast determination, so basically any fertilized egg has the potential to become a queen at the beginning, and the cast is undetermined until the larval feeding stage. So right from the egg stage, basically up until 3 days of the larval stage, that larva can become either a worker or a queen, and it really depends upon what that larva is being fed that determines whether it's going to become a worker or a queen. So for the first 3 days of that larval stage, the queen and the worker receive fairly similar but not exactly the same food for this first 3 days, and I'll cover that in the next slide. But after that 3rd day, you're pretty much at the point of no return, where a worker larva cannot really become a queen anything past 3 days. So just covering the worker versus the queen larval feeding. So looking at what a worker larva would be fed. Within the first 3 days, there's you would see about 140 feedings by nurse bees, whereas a queen larva would have about 1,600 feedings by nurse bees. So those queen larvae are being fed way more than the worker larva, and so they're receiving a lot more brood food, a lot more nutrition, and that really switches on the genes for that larva to then transition to becoming a queen. If we take a look at what that diet is actually made up at, the worker worker jelly, as it's called, which is kind of low in protein and high in sugar. For the first 3 days of the larval development, there's there's secretions both from the hypopharyngeal glands and from the mandibular glands in the worker bees. And so for the first 3 days, that worker jelly is made up of about 70% hypopharyngeal gland secretion and about 30% mandibular gland secretion. The queen larvae are being fed the royal jelly, which is a lot more high in protein and has a lower sugar content and contains a lot more proteins and fatty acids, amino acids, and vitamin B. And so this royal jelly is going to contain about 50% hypopharyngeal gland secretion and about 50% mandibular gland. So fairly similar to what the worker larva is being fed for those first days, but a little bit different. The queens after that stage are going to continue to be fed only royal jelly for the rest of their development, whereas the worker bees are going to kind of switch to a combination of hypopharyngeal gland secretion, but also a mixture of honey and pollen. So there's multiple ways of rearing queens, and so I'll just kind of touch on some of them, and then I'll spend most of the presentation talking about the grafting method. But again, as I mentioned, you can rear queens by doing these walk-away splits. You can just take a queenless split off of a hive, put it down, let it rear its own queen. You have a lot less control if you do something like that. They're kind of open to just selecting whatever larvae they want to select, and as I mentioned, they may select an older larva, and it could result in an inferior queen. The OTS, or the on-the-spot method, I won't go into too much detail. If you're really interested, I know Brad Hogg did a workshop a couple of years or a few years ago, and there's a pretty good video on YouTube of that entire workshop. But basically what you're doing, you have a little bit more control. You set up a queenless split. You would then take a frame of eggs and young larvae and just kind of pull down the comb, either using your hive tool or you can use a pen or a pencil. And basically what this does is it kind of mimics the beginning of a queen cell. The bees are going to see this broken comb that's pulled down. They're going to start rearing a queen in one of those cells. So if you find a cell like this with a really, really young larva that's somewhere around a day old, you can select that and basically tell the bees which or where to start building queen cells, and you can have a lot more control in rearing some better queens that way. There are a number of queen rearing kits out there. There's what's known as the Genter kit, as well as the Nicot kit, and basically these kits, you don't have to do any grafting. You basically put this little frame into one of your frames in your colony, but you can basically exclude the queen into one of these frames. The queen will lay in all these little plastic cups, and then you can remove this entire little frame here and pull out those plastic cups and just basically place them right onto your grafting bars here, and then put them into your cell builder colony and let them rear out their queen cells that way. So no grafting involved. I've personally never used one of these. I know a lot of people really like them. I've always just kind of relied on the grafting method myself, but that can be a much easier tool for someone just starting out if you want to try that method. So the Doolittle method, which is the grafting method, is the method I'm going to cover for the duration of this presentation. So first off, there's 3 basic steps in rearing your own queens. First off, you would have to select your queen mother or your colony that you want to rear queens from. Second step would be your queen cell production, so actually setting up your cell builders and your cell finishing colonies. And then the mating process would be the final step. So first off, the queen mother selection. So when you're selecting a colony that you think you would want to rear queens from, there's a number of desirable traits that you can look at. And I have a slide at the end that kind of touches on basically all the things you might look at if you want to get into bee breeding. But some of the easier things that, beekeepers just getting into queen rearing can look at. For sure, you want to look at gentleness or defensiveness behavior. You don't want to be selecting from colonies that are highly defensive and are, going to be stinging you every time you go into the colony. And not only that, if you're selecting for colonies with defensive behavior, you might piss off your neighbors and that sort of thing. So you should really always be selecting from colonies that have a gentle nature to them. You want to select from colonies that are free of disease. So you don't want to be rearing queens from colonies that have, American foul brood or chalk brood or things like sac brood. These colonies are going to be, vulnerable to these diseases, and the queens that you rear from those colonies are also going to be vulnerable to those diseases. You could look at spring buildup, so how fast that colony is building up in the spring, the amount of brood in that colony when you first crack it open in the beginning part of the season. You could also look at, the total colony size, right, in the peak of the honey flow. You could for sure look at things like honey production, hygienic behavior, if you like, and I'll cover some of the other things on my last slide of the presentation. But hygienic behavior, the KRTP does have a service if you're interested in starting to select for things like hygienic behavior. I can come out and bring some liquid nitrogen. We can do some hygienic behavior testing. But if you're just starting out, pick your best colony and graft from your best colony. You don't have to make it more complicated than it needs to be. If this was your best colony in the right in the middle of the season, it produced the most honey, it had no disease, and it was a fairly gentle colony, maybe pick from that colony and you can propagate some of those genetics. And if you don't have, or if you don't feel that you have really good genetics within your operation, maybe you only have a couple colonies, small beekeeper, maybe ask your neighbors or, someone else within, your beekeeping association if they have some really good colonies that you might be able to take a frame of larvae from to graft from, and maybe you can repay them with a queen at the end or something like that. So the second step would be queen cell production. So the overall requirements for queen cell production would be the larva from the initial colony that you've selected. You would then set up a cell builder and a cell finisher. You don't always need a cell finisher. You could just have your cell builder colony and do all the work from starting to build the cell to finishing it itself. I've done both, and I find both work. I've had pretty good success with just using the cell builder method, and I've reared some good queens that way. But generally, you're going to get a little higher quality queens if you end up putting them in a finisher. And I'll touch on what those are in subsequent slides. You then also need some queen rearing tools. So what are these queen rearing tools? So first off, you need some queen cell cups and a cell bar frame. So this would be a typical cell bar frame that you could use. You can purchase these frames with these bars that are used for holding your queen cells that are manufactured, or you could kind of manufacture them yourself, just using a bottom piece of a frame that has a slot in it that you can use to hold these queen cell cups. The queen cell cups, basically there's two types. You can either buy the plastic ones or there's the wax ones. I guess kind of a matter of personal preference. I think some people probably prefer the wax ones over the plastic ones. I think I've probably only ever used the plastic ones, and I've had pretty good success with those. You could also use a frame rest. It's not necessary. You can just kind of take your frame and lay it down, and you do want to prop it up on something. It makes it a little bit easier to see down inside the center of the cells and be able to extract the larva. So you can buy a frame rest like this, or make up your own, or just kind of jerry rig something yourself. Grafting tools. This one down here is a Chinese grafting tool. This is my particular favorite. It has a little piece of plastic kind of on the bottom, and then a little wooden piece here that this is a spring-loaded device that has a little thing where you can just push down with your thumb. So basically you reach down into a cell, get a tiny little larva onto the tip of that grafting tool, and then you can kind of use that little plunging device to push that larva down into a queen cell cup. There are a variety of other grafting tools out there. There's ones like this that just have this kind of tiny little hook on the end. There's other metal ones. I know some people make their own just using, you know, a long piece of metal and kind of bend a little tip on the end. But I really like these Chinese grafting tools. I think they work really well. A light source is very handy when you're doing something like this. It's quite hard and difficult to see way down into the bottoms of the cell, and as I mentioned, the larvae that you're after are basically the smallest ones you can find, and you can barely see them down at the bottom of the cell. So having a light source will really come in handy to see those larvae at the bottom of the cell. Having some royal jelly can help. It's not necessary, but you may get some better results if you prime the bottoms of your queen cell cups. If you just take a little bit of royal jelly and put it down at the bottom, just to have something for that larva to start off on. So there's, you know, you can buy dehydrated royal jelly powder and just mix it with a little bit of water and just take a little bit and put it down at the bottom of that cell. You could also, if you you know, are doing this in swarming season where there's a lot of swarm cells, you can just collect some swarm cells or something from some of your colonies, and you can use that royal jelly to prime your cells that way. Having some sort of queen rearing calendar really helps, just to, you know, keep you on track and you know, write down a schedule of when you should be doing things. So you can find these online. I would like to develop one with the KRTP, and I'll do so this coming year if I can find the time. Hopefully I'll be able to actually put one out before the queen rearing workshop comes along, and maybe be able to supply them to the participants of that workshop. But yeah, basically, you know, you have the days of the month kind of on the outer wheel, and then all your activities down on this wheel, and that wheel just kind of spins around, so you can line up when you're going to be grafting, and well, first off, line up when the queen's going to be laying eggs, and then line up when you're going to be doing your grafting, and then you can kind of calculate when those cells might be capped, and then when you might want to move them to either a finisher, or you can move them to a split that you've prepared. So something like this is super handy to have to really keep you on track. So the overall queen rearing technique is, as I mentioned, you want to graft the smallest larvae you can find, so less than 24 hours old. This is a picture I found online. So the one labeled A here is about the age of the larva that you want to find. Super tiny larva. This one here labeled B is probably going on 3 days old or so. It's quite a bit bigger. So if you see something like that, you can probably leave that one. And I find in general, just with the way the queen is laying eggs, and those, the eggs kind of on the outer parts are going to start hatching first. So you can kind of find where the eggs are on the frame. Look just kind of on the edge of where the eggs are, and generally you can find a lot of really, really young larvae that have just hatched. This is just an egg down here labeled C. So yeah, I kind of touched on some of this, but how to get the young larvae to actually graft. So what you can do is place an empty frame into your brood nest about 4 days before you actually are going to graft. So if you have, I find something with black foundation works really, really well. You're going to be able to see the young larvae a lot clearer than white foundation or an older frame that's a lot darker. So if you have some newer frames that's freshly drawn out comb with some black foundation, that would be a great frame to put in. So you can put an empty frame down about 4 days before you do your graft. That as long as that queen gets on and starts laying right away, 4 days later you should be able to find some really young larvae to be able to graft from. You can also confine the queen. So you can you can either use on the left here a single frame queen excluder. So basically just a queen excluder surrounding a whole frame. You can put a whole frame down and exclude the queen, so you know exactly the frame that she's going to be laying on. You can also do kind of a DIY method of just using some hardware cloth, press it into the comb over top of the queen, let her lay some eggs in that little section, and then you can be sure that that section is going to be the right age 4 days later. And then you can also just choose a frame with eggs and larvae on it if you like, and just kind of search around the frame for that. Some people have good enough eyes to be able to find young larvae that way. Other people might want to rely on one of these other methods of increasing their chances that they're going to be able to find those young larvae. As I mentioned, there are these queen rearing kits, the Genter or the Nicot system, that basically have these kind of built-in ways of confining the queen. So you just put this into your comb, put the queen down in there. There's actually a little plexiglass cover here that you take off. You put the queen in there and let her lay into those little plastic devices that you would then just remove from the back. So the overall queen rearing technique, I'm just going to be covering the grafting method or the Doolittle method. So first off, you want to transfer a larvae to an artificial queen cell. So you can see this guy down here is just removing those young larvae and placing them into he's got his grafting bar all ready to go with his artificial queen cells placed into his grafting bar that way. You do want to do this in a pretty humid environment. The larvae can dry out fairly quickly, so you want to be pretty quick about doing your grafting. You don't want to start it and then go take a phone call or something, and those larvae will probably dry out on you. But if you can do it in a fairly humid environment, that would be really good. A lot of people just do it in their truck somewhere in a enclosed space. Other people have special grafting shelters that they've made themselves and keep them fairly humid. So you would do your grafting onto your artificial queen cells and put those cells into a colony, and you'd flip them upside down so those cells are all pointed downwards. And really the cell orientation and the queenless condition of the cell building colony is going to cue the workers to feed royal jelly to those artificial queen cells that you've grafted into. As I've mentioned multiple times, you need very small and young larvae. These are going to make the best queens for you. you want to handle them very carefully. You don't want to be poking a larvae and smushing it or anything while you're trying to graft. It takes quite a bit of practice, but I think it's something everyone should try out, and you'll get better at it as you go. Your first year you might not have great success, but I think as you practice and practice and practice, you're going to get much better at it. I did mention that you can prime your cells using royal jelly, and often this will result in a little bit better acceptance. The cell building colony will be more likely to build out those cells that have been primed. But a lot of, probably more experienced people that do queen rearing much prefer just to do dry grafting. It's a little quicker. They don't have to make up royal jelly and add them to their queen cells. And basically, as long as I think these Chinese grafting tools work pretty well in that regard, because you can get right down into the bottom of the cell and scoop up a little bit of royal jelly or worker jelly with that young larva, and then be able to place both the larva and a little bit of royal jelly down onto that artificial queen cell. So it's not necessary to prime those queen cells, but probably if you're using a different tool, it might be a little bit more necessary. So your cell building colony, so I'll kind of touch on the cell builder and finishing method here. So your cell builder should be a super strong queenless hive. Basically, you want to make it as strong as possible. It should be queenless for at least 24 hours. So you could go in either a day or 2 days before, find the queen from whatever colony you're going to be using. It should be a healthy colony to begin with. So probably, pick one of your stronger colonies, remove the queen, place her off somewhere. Maybe you want to make up a small nuke box with the queen, just to kind of house her for the amount of time that you're going to be using this cell building colony. And then you really want to also remove any open larvae from that colony. You don't want the bees using up, their brood food that they're producing on any other open larvae that's within that colony. Basically, you want to remove that and allow those glands that the worker bees have to just become as engorged as possible, and just prime those bees for wanting to do nothing but feed young larvae. So you can put emerging brood in there. You want an abundance of nurse bees, so you can bring in emerging brood from another colony, and you can boost that queenless hive. That brood would start then emerging. All those young nurse bees would be developing their glands and be producing that hypopharyngeal gland and mandibular gland secretion to produce that royal jelly that's going to be then fed to the larva. So the other thing you need in this cell building colony is ample resources. So if you're doing this in a honey flow, you don't necessarily need to feed the colony, but if you're doing it in, say, the end of May or something like that, you'd probably want to put some supplemental syrup on there. The colony just needs ample resources to be able to put all that energy into rearing those queens. For sure, you want an abundance of pollen. So if you can find some pollen frames from another colony, or if your cell builder already had some, you want to put that pollen very close to where you're going to be adding that grafting frame. And probably the most important thing about setting up your cell builder is that you should have no queen cells. So if you're removing the queen a couple days before, that colony might start producing queen cells within the time before you actually graft. And so if you just put your grafted cells in there, if there's any queen cells in this colony, those queens are going to emerge, and then they're going to run around and kill all of those nice cells that you grafted, that you've put so much time and energy into. So you have to make sure there's no queen cells when you're adding your grafting frame. So probably what you would want to do is, go into that cell builder in the morning, go through every frame. There can always be a queen cell hidden off somewhere. Shake all those bees off of each one of those frames, inspect every frame in the colony, make sure there's absolutely no queen cells in there, and nick them off if there are. And then you can be sure that that colony isn't going to rear its own queen and kill all your queen cells. You probably want to check it again, even after you've added that grafting frame, just to be sure that your cells aren't going to be killed by any queens emerging. You would then, the grafted cells would then be given to the colony for about 24 to 36 hours. So if you're using the cell builder, cell finisher system, you would only stick that grafted frame down in there for about a day, or 2 days at the most. Let those cells get started, and then you would then transfer them to a finisher. And so basically what we're mimicking here is kind of the a hive that's about to swarm. So we're kind of mimicking that swarming instinct. A colony that's has ample resources and is about to swarm is going to produce, is going to have that drive just to start producing those cells. But a colony that's actually queen right will actually produce higher quality queen cells. So your cell finisher would actually be queen right. So after 24 hours of putting your grafted frame into your cell builder, the cells would be filled with royal jelly and extended to about 6 millimeters. So this picture probably shows queen cells that are a little bit bigger than 6 millimeters. It'd probably maybe be only about half of that length. So they'd just be just that little bit, but they'd be the bees would be starting to fill with royal jelly, and starting to actively produce those cells. So you could take out your entire grafted frame and then transfer it out into a cell finisher. So your cell finisher, as I mentioned, is a queen right colony. Importantly, the queen should not be able to have access to those cells that you've put all that effort into producing. So this would be, a second brood chamber on top. Find a good strong colony. Put a queen excluder in between that first box. Make sure that queen is first off down in that bottom box. Put a queen excluder on it, and then you could remove one of those frames in the top brood chamber and add your grafted frame down into the top box. Again, you need ample resources in this cell finisher colony, so you'd want a lot of honey and pollen. Maybe think about supplemental feeding if you're doing this outside the honey flow. You'd also want frames of young open brood beside your started cells to draw the nurse bees into the area. So you want to attract those nurse bees into the area where you're putting your grafted cell, to be able to put all those resources into your grafted cells. The cells would then be capped after about 5 days. So if you think back to the life cycle or the development of a queen, if you take away those 3 days of that queen, the egg stage, you'd have about 6 days of entire larval period before that larva would be capped, before that cell would be capped. So if you're grafting on day 1 of that larval stage, your cells would be capped after about 5 days. So your cells can either be left or right in the finisher to hatch. There are these kind of special cages that you can place over top of your queen cells, so that, you know, once your queens actually emerge from those cells, they're going to be caged immediately. Or you could actually move all those cells to an incubator if you have one. You can make one up yourself using, you know, I've seen beekeepers use an old freezer or an old fridge to kind of make a makeshift incubator themselves. Just put like a light bulb in there or something to keep it quite warm. You'd also want to, you know, make sure it's quite humid in there. So put, you know, a little tray of water or something to keep it humid. Your incubator should be somewhere around 50 to 70% humidity and about 35 degrees Celsius. So you can move these cells basically any time within that 5 to 11 days after grafting. So as soon as those cells are capped, you can then move them. You don't want to wait any longer than about 11 days. Your queens might start to emerge after that. And if you don't have, you know, cages over top of them, any queens that emerge would go and kill all those other queens. So your queens will start hatching about 12 days after grafting. You could also transfer your cells directly to mating nukes or any queenless splits that you made up. So there are kind of a number of different ways you can make up mating nukes. There's, you know, commercially available mating nukes that are, you know, just these really small boxes where you don't need a ton of bees. You just put in enough bees that are going to be able to take care of the queen when she emerges, and then she would go off and mate with other drones in the area. Or you can make up, you know, larger queenless splits using nuke boxes, or you know, you can even use you know, full-size box as a queenless split, or if you have a full-size box, you can divide that full-size box by, you know, putting a piece of wood down the middle, and you can have basically 2 mating nukes in one box. So you can kind of do it any number of ways, but you could just transfer your cells directly to a mating nuke and let the queens emerge immediately. As I mentioned, a queen ring calendar is really useful to have. So you can either have, you know, a calendar or something like this. I think you can probably find something like this online, or you can have, you know, your the wheel that I showed you, the queen ring wheel. But basically, you know, it kind of lays everything out for you. Your brooder queen is going to lay her eggs. These eggs are going to hatch on about day 3. Day 4, you're going to want to start grafting your larvae when those larvae are 1 day old. Day 8, those cells are going to be sealed. Day 8 or 9, somewhere around there. Day 13, day 14, those cells will be out of your cell builder and into a mating nuke. Your cells will then hatch on around day 16, and so this is also taking into account the 3-day egg period here. So if you didn't take that into account, it'd be somewhere around day 12 or day 13 that your cells would actually hatch. Your queens would have to then become sexually mature, which takes around 5 or 6 days to occur, and then she would then go on a mating flight, and then the queen would begin laying up to 4 or 5 days later. So yeah, as I mentioned, that you can use a queen ring wheel to kind of plan all that out as well. So your mating nuke, kind of touched on it already. It can be, basically any small queenless colony. You could introduce the cell either 1 or 2 days before emergence directly to the queenless colony. Or you could introduce a virgin queen if you allowed your queens to emerge either in your incubator or in your cell finisher. the queen, as I mentioned, would then become sexually mature within about a week, 5 days to a week. And the queen would then begin laying about 2 to 4 days after mating. Mating, it could be delayed. The queens need good weather conditions, at least 20 degrees, good warm conditions to actually go on mating flights. So in really poor conditions, if that queen hasn't gone on a mating flight, it could be delayed up to 3 weeks and still be successful. So if you're checking on, if your queen has been mated and if it's laying, if you're, 2 or even 3 weeks out and you still haven't seen eggs, you could, be a little bit patient and maybe wait 3 weeks to a month, and you may still see signs of that queen starting to lay eggs, even up to a month later, if you're in a period of really poor weather when that queen should be mating. So just to kind of tie things up with honeybee breeding, so queen rearing is not the same as queen breeding. Queen rearing just kind of refers to, all those, the actual method of removing and doing the grafting and, setting up your cell builder and all that sort of thing. Queen breeding actually is a lot more detailed and a lot more labor intensive. You really would have to keep a lot of records on the colonies that you're going to want to use for your selections. So you'd be taking a lot more steps to actually go through a queen breeding program and actually selecting for a lot of different traits that you want to put into your stock. So this is just kind of a list of most of those traits that you might want to select for. So low defensive behavior, honey production, overwintering ability, spring buildup, low swarm intensity, solid brood pattern, comb stability, so how calm the bees are walking on the combs, things like hygienic behavior, grooming behavior, longevity of the queen, so how long the queens can actually live for, resistance to other diseases or the absence of other diseases. So some bees might be actually resistant to things like nosema or chalk brood or sac brood, and also tracheal mite resistant. So you could start, if you want, selecting for some of the stuff. Some of the easier things that you'd be able to look at, of course, is things like defensive behavior. You don't really need to be keeping notes for all of these things, or be doing these sort of experimental things in your bee yard. So you could look at honey production. It's usually pretty obvious which colonies are producing the most honey, which queens are able to survive. So selecting from stock that has maybe survived at least a couple years, looking at which colonies build up the fastest, that you should be able to quickly pick out some of your best colonies that way. Things like hygienic behavior and grooming behavior are a lot more difficult to select for. You need to spend a lot more time in your colonies and be keeping good records and oftentimes performing more kind of experimental methods and over multiple years. And when with a proper queen breeding program, you should have a large number of hives that you're actually testing. So you have a large population that you're actually selecting from. So that is about it for the presentation. I'd be happy to open it up for questions.
Awesome. Thank you very much, Derek. That's a very comprehensive presentation. One quick thing though on record keeping. It's sort of like the dirty laundry bit about beekeeping, where people have a tendency to go out and check their colonies, rushed or thorough, it doesn't really matter. But it's like, oh, I'll remember exactly what's happening in this hive like 10 days from now. And let's face it, that just doesn't work. But like when you are trying to identify you're really strong or you're really productive or you're really or those colonies that have that particular trait that you desire. Record keeping is really key for that. And if you don't have the time to be scribbling down notes, everyone carries a phone, and just record yourself. Just record yourself with a dialogue, and at your leisure, in front of your computer, you can dictate and make rapid notes later on. But it really makes a huge difference and has saved colonies just by eliminating mistakes. So I know,
Yeah,
I'm a big fan of that.
absolutely. Yeah, I find even as soon as I hop up to the next colony, I almost forget what was going on in the one before it. So yeah,
Especially if you're running, like, if you've got 4 yards of 40, well, unless you're Johnny Mnemonic, good luck. I just need to switch the view to gallery. If anyone has any questions, can you, we'll start off, and would you like to raise your hand, please? I've got one in chat that we'll start off with. This is from Lynn's iPhone. If you want to augment drone numbers to enhance mating, where are drone frames best used? Do you transfer one drone frame to a mating nuke from a regular brood chamber?
yeah,
Go ahead, Jarek. You can.
I didn't really touch on it, and maybe I should have. If you want to increase drone numbers, you can do so, but you kind of milk drones, and you probably want to do so out of some really good colonies. So pick some colonies that you like those genetics, and milk those drones out of that colony. You can put specialty drone frames. They sell those green frames, those drone frames that you can buy, and throw those into your colonies to rear some drones that way. Or if you have some other drone comb lying around, you can kind of throw that into your colony, milk those drones out. And you'd want to put those into the mating yard, so you can kind of flood your mating yard with drones of good genetics. So just having them in the yard somewhere should be good enough. You don't necessarily have to have them right in the split you're gonna be putting a queen cell into. Just having them somewhere in the yard where once that queen goes out on a mating flight, those drones are going to be in the area and attracted to that queen.
And also in chat, there's a quick question. How can you elaborate on how to transfer a queen cell to a nuke? Like, I know with mating boxes, there's usually a frame with a little clip where the queen cell, the plastic part of the butt of the queen cell will let it hang there. But if you were going to take a queen cell to a nuke, I know that making sure that you're not bumping it around or turning it in different directions is key. But is there any other tips of handling them carefully, or how you would to wedge them in and where on a nuke?
Yeah, you definitely want to be really careful handling those queen cells. You don't want to be bumping them around too much. They will be able to withstand a little bit of handling, so they're not, just by touching them, you're not going to kill the queens in there. But there's that probably really expensive thing that it's called the carry cell, I believe, that you can buy. It's kind of like a little metal toolbox that's a little incubator. It keeps the bottom of this little toolbox thing at a warm temperature, and it has a soft foam area where you can just stick your queen cells down, and it's going to hold them in place really nicely. You're going to be able to carry this thing around and not be banging your queen cells around. You can also make your own little incubator type thing to carry your cells around, just using a small cooler and some wood shavings. You can put some warm water into a Ziploc bag, put it down at the bottom of the cooler, put some wood shavings on top, and then just kind of lay the queen cells on top of that. It's going to be nice and soft for those queen cells, and then you can just kind of carry the cooler around that way, and it's going to be nice and warm in there for those queen cells. You can carry them to a different yard if you want, and then putting the queen cells into a frame. you can, push it right into the wax. You don't want to push it too hard that you're going to damage the actual queen cell, but you should just be able to place it right into the face of the frame a little bit, just so it's nice and held in there, and then snug it up nice and gently with one of those other frames so it's not going to fall to the bottom.
Thank you, Derek. Brad, your hand is up. Can you unmute your mic?
Thanks, John. Derek, I used last summer, is pretty much my first time of really taking grafting seriously at all. I used, as you suggest, the starter and finisher, 2-hive starter and finisher configuration that you talked about, along with an incubator. I absolutely love that combination, that process. Some texts talk about using a starter finisher in one colony. Can you talk a little bit about why a person might choose one or the other?
I'm assuming you might be talking about the cloak board method. Is that kind of what you're getting at? Or?
No, a queenless finisher, I suppose. You'd use one builder for the entire process. So you'd put you'd have a strong queenless hive for your starter, but you would just let that hive complete the cells and go right to, before emergence.
Yeah, I mean, I suppose it's time or maybe a resources kind of thing. If you don't have, that amount of time to go out and set up a finisher, or I mean, and it does work too. So you don't necessarily need to set up the finisher. The cells typically will end up a little higher quality. A queen right colony will usually result in larger cells. They'll be feeding a lot more royal jelly and be able to produce some more superior cells that way. But, you might not have, if you only have one colony or a couple colonies, you make one queenless, you have your cell builder colony. You could just use that queenless cell builder for the whole thing. Yeah.
Rob, you have your hand up. You have a question?
Yeah, thanks. Thanks for that presentation. It was really great. I'm wondering if you could talk a little bit more about using swarm cells as a source of queen cells. I know you mentioned that there would be a tendency for the hives that were the product of that to have a higher tendency to swarm. But I'm thinking maybe that depends on the time of year that you harvested the cells from a swarm. So for example, if it was a swarm that was occurring early in the year, that might have a tendency to swarm, but something that would be swarming in late June or early July, that would seem to me to be a relatively natural process, and you wouldn't have that, you wouldn't be introducing that tendency into your apiary. Just wondering if you thought that was reasonable, or you had some other thoughts on that.
Yeah, I can elaborate. I think what I was getting at is that swarming has a genetic component to it. So if you're using swarm cells to make up splits, you'd be introducing those genetics, and the colony is, not necessarily going to swarm, and definitely may not swarm that year. If you're making it up midsummer, that colony is going to build. It probably that year won't get to the size that it's going to swarm again. But yeah, basically what I was just getting at is that you're introducing those genetics. If it's just something to think about if you're using swarm cells, to requeen colonies. It's definitely a viable thing for beekeepers to do, and it's an easy way of obtaining cells. If you see a swarm cell, just cut it out and make a split, and you've got another colony. So definitely a easy, viable way to increase your colony numbers. yeah, just kind of throwing that caution out there that you may be kind of over time selecting for swarming behavior.
I'm just going to shift over to chat where Lynn is asking, is the summer solstice a factor in queen rearing?
I saw that one pop up, and trying to think if that's a factor for any reason. Probably is that I'm not thinking about at the moment. It might just be, getting later into the season that you might not want to rear queens too late into the summer. I think the summer solstice would probably still be okay. It depends. Once you get a little bit later into the season, there's, going to be less opportunities for queens to go on mating flights and that sort of thing, and maybe less drones available as well. So the later you get into the season, the less likely you're going to get a really good mating. But I think grafting, even, into probably the beginning of August. So maybe that's a rule that I haven't seen, that you should not graft after the summer solstice, but I haven't seen that.
Okay.
But yeah, you probably don't want to graft too much into August, because the amount of time that those queens take to emerge and then become sexually mature and going on mating flights really, ends up putting you into September, and way less chance of going on a successful mating flight at that time of year.
Okay, I'm doing these questions in order, so people that have their hands up, please keep them there. We will get to you. Rebecca is asking if you could quickly show the finisher hive slide again.
Yeah, sure. There's a couple of finisher hive slides. Do you mean the first one?
Oh, let's assume that one. Veronica, you were asking quickly review of what the finisher, what it consists of again. So a finisher hive is going to be mostly populated with bees of a certain age that are well into their wax production to finish off those queen cells. And the slide is pretty self-explanatory on where you want the composition of that as well.
Yeah, and maybe I'll mention too, like one kind of a trick that you can do to not get as much burr comb on your grafting frame is just put a frame of foundation somewhere in there as well. So, if the bees really want to build comb, they'll do it on the frame of foundation, and you'll end up with some much cleaner cells that way.
Great, thank you. Mark, I believe you had the next hand up. Can you unmute your mic and ask Derek your question? Hi, Mark.
Hi there, Derek. Great presentation. You mentioned.
Okay, Mark, you're not coming through very. You're not coming through clearly. If you shut your camera off, it'll boost your audio, and you'll come through better.
Can you hear me?
Yeah, you're a little bit choppy. Try again.
Maybe you could also type it into the chat, Mark, if you want.
Yeah, and then we'll get to it.
Me?
Yeah, please. Yeah, type their question into chat, Mark, and then we'll be able to address it. You're just coming through pretty broken. Brad, your hand is up next.
I can't be quiet for long. I had such a great time grafting last summer that I just bubbling over with excitement. And Derek, your slide that said, you know, for no other reason, it's the most fun and cool thing you'll ever do with bees. I couldn't agree more. It's just amazing. I just wanted a quick little experience comment on the solstice question. Yeah, everything Derek said, that, you know, you can't get too late. What are you going to do with that queen? Are you going to make a nuke that you want to winter? Or are you going to replace queens in something? You have to work that all out. But in what I've experienced in raising queens is my mating success goes absolutely through the roof in July. So I might be looking at early to mid-June, you know, I'll be looking at 75% mating success, etc. I get into July, I'm 95% and higher, 98% mating success with these queens. And the quality is absolutely spectacular. So that was just my own experience noticing that with my raising queens over the last 2 or 3 years.
Yeah, I mean, probably like late June and into July would be the best times to be raising queens. I don't
just
know.
Good weather, right?
Yeah,
it's
good
July,
weather.
it's dry
yeah,
and warm, and
ample amounts of drones, and
drones
you know,
love it.
Sexually mature drones.
Yeah.
I don't think I mentioned it, but the drones take about 12 days to reach sexual maturity after they've emerged. So, you know, you're looking at 24 days for the development of a drone plus 12 days for sexual maturity. So that's, you know, well over a month before you start seeing a lot of drones being produced in your colonies to the time when there's going to be ample amounts of drones that are sexually mature.
Mark's question in chat, Derek, is can you please expand on the treating for mites, specifically the timing, and if it will affect the mating of the queen?
Yeah, I mean, you probably wouldn't want to have any mite treatments in your cell building colony. So
I guess he might be expanding on if there's a presence of mites, will it end up going into the queen larva or the queen cups, and how detrimental is that?
Yeah, that's a good point. Yeah, I mean, it's possible. I don't think I've heard of mites going into queen cups, but it could very well happen. I mean, I mean, you want to always keep your colonies in general as mite free as possible. So, you know, if you are able to, you know, do some mite washes on some of your stronger colonies and maybe end up choosing the one with the lowest mites in there, not only will it have the lowest mites, but it would have the lowest virus as well, and probably be healthier than a colony with a higher population of mites. And yeah, I would say, you know, try to treat your colony first before you turn it into a cell builder. You wouldn't want to, you know, have something like formic acid or something in your colony while you're rearing queens producing cells.
Very good. Ron, you had your hand up. Can you unmute your mic?
Yeah, I'm a really, really new beekeeper, just 1 year under my belt and just a small hive. But I was looking at your slides, it looked like you're making, you know, a dozen queens at once. You know, can you just do 1 or 2? And how long can you have a queen hang around before it has to go into like a hive? Like, you wouldn't make them unless you needed them or wanted to sell them. But I'm just trying to figure out of how long before a queen has to be in a full hive.
Like, how long can it remain caged? Because
yes,
it can stay in a mating nuke until it runs out of room, and it can be transferred into a nuke box until it runs out of room. And you have to understand that when you're purchasing a queen that's $45 a bug, the reluctance to crush it is very, very high. When if you are turning around and you're selecting queens from the best cells, or if you had ones that you know, and again, good record keeping suggests that maybe these are better than those, you can either try to sell them off and get them off of your hands. But if you've got oodles and oodles of queens and nothing to do with them, I mean, it tugs the heartstrings, but destroying them is also another option, right? So Derek, can you follow up on that?
Yeah, I mean, and you can do only one or two. I mean, you could use the grafting methods for only one or two, but might not make so much sense to go through all that trouble to, you know, set up a really strong cell builder and just produce one queen. You might want to go with something like the OTS on the spot method, or something like that, or maybe just throw a frame of eggs into a queenless split and do it a little bit easier if you're not going to be mass producing queens. But in general, I think the guidelines for if you have a full colony that's set up as your cell builder, you can make upwards, I think, of 90 queens in a full size colony. Although that's probably pushing the limit a little bit. You probably want to come back to maybe 30 or maybe 60. Usually you can fit about 30 onto a grafting frame, 10 on each row kind of thing, and have a couple grafting frames that you could place into there. So you could go, I'd say, up to about 90. I think I took a queen ring workshop with RRAA one time, and I think that was his recommendation too. But if you can use a smaller, just a nuke box as your cell building colony. But if you're going to be using a smaller cell builder, you wouldn't want to go for that many queens. Probably one frame would be your maximum. So about 30 queens.
Okay, thanks.
Laura, you had a question for Derek?
More just a comment for the timing of watching for if they've made it. Just know that if you're waiting that 3 or 4 weeks, you're gambling with laying workers too. Like if you don't actually see the queen in there, to watch out for that.
Yeah, good point. And I think it might have been you actually, where I think you were doing some queen ring and you didn't notice your queen actually laying until like almost a month later. And I think it was the queen, if I'm not mistaken.
That time I had a bunch that I should have been dealing with them. I checked them on the Thursday, they weren't laying. I was like, I'm going to deal with them on Monday because we were going camping. And it had already been, I think, 2.5 weeks. So when I came back, they were all laying. So that time I had stretched it. It was probably almost at the 3. I'd have to look back how long it was, but it felt like a really, really long time. And it was scary because I had sold most of my queens with my nukes. So I didn't have a lot of queens in the yard. So in that case, it did, but just something to watch out for too is laying workers.
Absolutely, yeah. You definitely run the risk of, having your split turn into laying workers and having to dump them in the bush or in front of a strong colony or something. So yeah, good point. Thanks.
Yeah, and that year the weather was terrible for meeting, so that was a factor too.
Cool. Just lower your hand there, Laura. Do we have any other questions for Derek? We're running at like 5 after 9, so we are running a little shy of time, but Lynn's asking, can you graft eggs or just young larvae?
Yeah, generally you just want to graft the larva. I don't think I've ever heard of anybody grafting eggs, and I think they're just too fragile to move them around. Probably as soon as you take them out of the cell, they'd fall off your grafting tool or blow around or something. And yeah.
Like if you want to be handling eggs and not larvae, then you might as well use a gender system, because that way, you're dealing with like the youngest of eggs and the queen's putting them in there herself. So I would say better success in that.
Hi, John, can you hear me?
Yes, I can.
Yeah, it's Gary. I can't find my hand to put up.
That's okay. We
I just wondered if why the problem with so many bees being lost this last summer, and have the mites mutated like COVID, or what's happening there?
as in for like why the mites were so predominant last fall?
Yeah, well, I'm under the impression that the mites were really difficult, or yeah, were being very successful in killing the hives this past summer. And
No, I mean, I actually was hearing that because of the drought and the hot weather, that mite levels were somewhat suppressed. But in the end, Gary, it boils down to you can have mites being a huge problem in a yard, and then 3 miles away, the hives, dealing with the mites very well. But it's more about beekeeping intervention and monitoring. People will get into a routine where they're treating their mites but not really monitoring their mites, and that's sort of where the troubles begin. If you don't know exactly any time in the seasons where your mite levels are at, you can assume you have a problem, because what you don't know is what hurts you. I didn't really hear anything about any mites or mutating or substrains or subspecies or anything like that. It was just more so of mites just inherently are really unforgiving, and they get to a certain past a certain threshold, and it's almost like you have to nuke the planet from orbit to get back into control. The key is to make sure that you're monitoring and checking, either with screen bottom board drops or with sugar rolls or washes, just to know. So
I could maybe elaborate too. I think, yeah, I don't know, John, if I heard that mites were suppressed because of the drought last year. I do think mites were a fair problem, and probably a bit more than normal last year. We did start the season quite early in March last year. We had some really warm weather, and that kind of got the season going quite early. And then we had quite a long, warm fall, and I think the mites last year really had a longer period to reproduce throughout the season. So I think that was probably one of more so the overall general themes that probably impacted a lot of beekeepers last year. I think some beekeepers were caught off guard, especially in mid to late fall last year, and had some really high mite levels that by the time they actually got around to trying to treat them too, that the damage had probably been done in terms of viruses and that sort of thing. So, but I mean, it definitely depends on the operation. I mean, if you had treated your mites really well and done everything properly, you probably would have been fairly in the clear. But then we also saw some really good beekeepers that had really high losses too. So I think the drought ultimately really ended up affecting colonies last year too.
I was hearing a few reports of people testing and monitoring for mites and finding very, very, very low thresholds. And then, like as you mentioned, like as fall rounded the corner, they just exploded, and it was like, well, where the hell did these come from, sort of a situation.
Yeah.
It's just like the season's over when the season says it is, not when you're done extracting. And again, it's just consistent monitoring and record keeping that really is key there.
Yeah, I was seeing like 4 frames of brood in some of my colonies at the end of October, and so
yeah,
those bees were going into winter with all that brood and all those mites still in the brood, and would have come out after wrapping or after those bees were put away.
Keith Bamford, you got your hand up.
Yeah, I just want to say on behalf, I just want to thank Derek for giving the talk today. I think we just all need to, he gave a great comprehensive talk on queen rearing, and I think as from the Red River Apiarist, I would just like to extend our thanks. Thank you, Derek. We really appreciate it. And I also wanted to kind of cut him off because we're not paying him for his mite advice. You know, we just are paying him for his presentation here on the queen rearing. You know, we just wanted to nip that in the bud. He wasn't going to earn some extra here. But thanks again, Derek. That's
Right.
really great.
No problem.
All right.
Yeah,
thank
I'll
you.
just plug again for the queen rearing workshop on
Yeah.
June 25th, very likely. And I know RRAA is speaking next month, so he'll probably have more to say on winter losses and stuff like that.
Excellent. And thanks again, Derek. And again, any correspondence or emails or announcements for that queen rearing workshop would be glad to circulate and publish in the newsletter as well.
Absolutely. Yeah.